Hi and welcome back to a new video. After all the new and fancy stuff from Computex, I thought it's time to talk about some older tech again, which will be this small card. First, it looks like an older, smaller graphics card, but this is not a GPU, it's a PPU. And if you want to know what a PPU is, that's what we will talk about in today's video. Save the setup fee on selected Hetzner servers during Euro 2024. Do you want to fully concentrate on your business and leave responsibility for configuration, updates and maintenance for your servers in professional hands? Then take a look at the managed servers from Hetzner. Until July 14th, you can get all managed servers without a setup fee. Hetzner is a GDPR-compliant hosting provider and operates several hundred thousands of servers in its own high-tech data centers in Germany and Finland. Hetzner is well known for its competitive price-performance ratio, competent support and innovative server solutions developed in-house, which is also the reason why I'm hosting my website there. Click on the link in the description and check out Hetzner for yourself. A PPU is a physics processing unit. That means we have a dedicated chip on this card that was meant to calculate real-time physics effects for games. The technology itself came from the Novodex AG in Switzerland that was developed from 2001 to 2004. And in 2004 the company was acquired by Ageia, which was a US-based company, which was then later in 2008 acquired by Nvidia. In case you're wondering what Chic is doing here, she's guarding the PC which we will use later for the testing of our physics processing unit. This is the dedicated physics processing card, in this case made by BFG with the Physics by Ageia technology. These were available from different vendors like BFG, ASUS, ELSA for example. And I'm happy to have one in my collection also with original packaging from BFG. And here you can see also the concept that Ageia was thinking of back then, and it's pretty much the same today. We had the CPU and the GPU as the base and brain and eye of our system, of the PC system. And Ageia back then thought, okay, we have to extend this with the PPU. This card was released in 2006, back then was made in 130 nanometer technology, which was at the time basically already old tech, because as just a comparison, an FX 5900 Ultra from 2003 was made in the same process node. So the GPU itself was not that much high tech, also the things around it. It came with 128 megabyte of GDDR3 memory, which was even at the time not that much. And it only had a peak power consumption of about 30 watt. You can also see that the connector on the bottom doesn't look like your typical PCI Express connector from nowadays. This slot though is normal PCI, which was introduced in 1993 and last time updated in 2004. That already shows you that the card, when it came to the market in around 2006, was kind of equipped with older tech, like the PPU. The manufacturing node was not that much up to date. Also memory 128 megabyte of GDDR3 and also the normal PCI instead of PCI Express. I guess they went for the normal PCI because of how the main boards were equipped back then. For example, this one is an older one. Came with an HDP slot for the graphics card, dedicated slot, but you always had expansion slots that were with normal PCI. And typically you would place your networking card or like a sound card in there, or in this case with a physics processing unit. The system today was also featured in a different retro build video which we did, and in there we had dual 7800 GT running in SLI. I removed them and replaced it with a 9800 GT. Also the first ASUS Matrix card, which could be interesting, and the CPU is a 4200 plus X2, so a dual core AMD CPU. And here on the bottom we have those PCI slots where we will place the physics processing card later. And because all of this is older tech, we have to run the beautiful Windows XP. You can see the 9800 GT running 512 megabyte of GDDR3 memory. Sorry for using the German driver, but should be no problem. Underneath this 3D settings part, you should usually find the setting for physics, which is not available here because it's also a quite old driver version. Physics by Ageia, as you can see. And this is a dedicated demo to showcase the physics effects that came with it. It was not that easy to install it and even to find it. And we will now run it first without the PPU in place. And I guess this demo is supposed to show some things flying around, maybe explosions, stuff, barrels, cubes, I don't know. I can't really tell because as you can see, it's only running with about 1 to 2 FPS, which is not enough to even guess what is going on. That means we will now place the PPU in the system and see how this affects the performance. After the benchmark is over, we can see on the right 2 FPS with software and apparently 35 FPS with PhysX hardware, which I'm not sure what this actually means. If this is a wild guess by the software, what kind of performance would be expected with the PPU. We will now place it inside the system. I hope it still works. That is something I have to find out now. By the way, that is a big difference to a graphics card. It doesn't have any connections or display output. Well, maybe I should have connected also the 4-pin modex. Okay, now it hopefully works. At least now I can see that the fan is spinning. There are also some LEDs inside the fan. That means that at least the card is doing something. Back in Windows, seems to be working at least. Now this Ageia PhysX logo popped up in the system tray. And also in Device Manager I can now find Ageia PhysX adapter, Ageia PhysX PCIe card. Opening the Ageia PhysX properties, we can find the Windows driver version, also the installed PhysX engines. And what I find interesting is that there is a demo included, the Boxes demo, which I tried to find as a dedicated download in preparation for the video, which I couldn't find, but it seems to be included in the driver, which is cool. But we're checking back into the reality mark. And now this looks a lot smoother. You can see explosions, somebody shot into the barrels on the right side. And definitely this is much better than before. At least we can see something happening. And this is something you wouldn't find in games back then because they did have some kind of physics implementation like that. And it looks pretty realistic and also now much faster, much smoother than before. Let's also check the PhysX Boxes demo. What we can do here is look around. There are a bunch of boxes stacked and we can just shoot a ball in here. See the nice interaction with the ball and the boxes, how it collapses. And that was tech that you wouldn't back then see natively implemented, at least, into normal games. And the things that we could just see in the benchmark were then implemented in a few games. For example, Ghost Recon Advanced Warfighter 1 and 2. Those were the games I personally also loved, especially the second part. And I was a big fan back then when I was shooting at the ground and things were flying into the air and then dropped back down and they stayed. Or for example, I was shooting at a wooden fence and instead of just collapsing in a predefined schedule or motion, you could kind of destroy things, or you could shoot at things in the air, punch holes into it, and also see trees moving in a much more natural orientation. So those were tiny things that made the games back then look a bit more realistic, but at a very high cost. And that was the big downside and big problem back then, because this PhysX acceleration card back then cost €300. And as comparison, an 8800 GTS 320 megabyte from around the same time was cheaper. So a dedicated graphics card, which was like a mid-range card, was cheaper than just the PhysX acceleration card that only gave you a tiny visual advantage. In 2008, NVIDIA acquired Ageia and fully integrated Ageia PhysX as NVIDIA PhysX into the driver. As you can also still find it nowadays. If you open the NVIDIA control panel, you can now select if you want NVIDIA PhysX to be calculated by the CPU or GPU, which could be relevant if you're, for example, not even using an NVIDIA GPU. In that case, your CPU might be doing the calculation. Back then, there was also a time, maybe from 2008 to 2010, where people were buying dedicated high-end GPU cards for the game calculation. So for example, you would get a GTX 280 and then equip a smaller card like an 8600 GT as PhysX acceleration unit. Because at that time, when NVIDIA implemented this as NVIDIA PhysX, you could run PhysX on any recent NVIDIA graphics card and thus just use a high-end card for the game itself and run a lower, older card as PhysX acceleration unit. EVGA also thought this is a quite nice concept of combining a high-end GPU together with a weaker GPU as a PhysX processing unit. And that's how the GeForce GTX 275 Co-op PhysX was born. I have two of those cards here. As far as I know, those are the only two versions that were ever made with just two different types of covers. apart from that, they should be identical, and I removed the cover of this one so you can see that this is actually a dual GPU card. This design and general layout might remind you of the GTX 295, which is because they share the same PCB, only that the GTX 295 was a high-end dual GPU running SLI, whereas here we have two different GPUs placed on this PCB. We have a GTX 275, which is a GT200B GPU, and we also have a GTS 250, which was at the time a pretty misleading GPU naming because it was using the older G92B GPU, which was commonly used in like a 9800 GTX Plus. And what they did is just using this kind of principle that you run like a high-end GPU for gaming and then assist it with a lower-end GPU for the physics calculation, and all this on a single PCB. Also removed the heatsinks for you quickly so we can take a look at the different GPUs. As I said before, the G200 on the side, that's basically the GTX 275, and here we have the G92B chip. That was, as I said before, commonly used on a 9800 GTX Plus. And the PCB is basically a GTX 295 and then just repurposed for this special co-op physics edition. Of course, I also want to use this chance to take a look at the Ageia PPU. They maybe cheaped out a little bit on thermal paste. I guess it's fine. I mean, the cooler, the heatsink is also pretty small, which I guess makes sense considering the power draw of max 30 watt for the entire card. And if I remember correctly, seeing tests from back then, most of the time the card consumed like 15 to 20 watt. Cleaned underneath the thermal paste, we can find the PhysX Ageia chip. As I said before, 130 nanometer was made by TSMC back then with a transistor count of about 125 million, which is about, for example, 150 times less than an RTX 4060, which is also a smaller GPU. So just as a comparison, you can see a lot of things changed over the years. Also just notice that my old PSU in there only has 6-pin connectors, and this card requires an 8-pin and a 6-pin. So I'm just going to feed it through an external PSU, but should be just fine. Maybe not as easy as I thought, at least when I switched on the PSU. I obviously switched on that PSU first. The card immediately runs at 100% fan speed, which is odd because normally cards don't start up before switching on main power over PCIe. I just want to check with the second card if it also immediately powers on if I just connect power and switch on the PSU. Obviously bridged the 24-pin connector, so the PSU immediately powers on if I flip the switch. Okay. Very interesting. Seems to be part of the card design then. Something I didn't have before. I will just replace it with this one and see if anything happens. I was too lazy to put the cover on. Oh, the fan is spinning slower, and yeah, we have display signal. Also looks good. The GTX 275 was already detected. In GPU-C we can find both GPUs, the GTX 275, which is from 2009 at least dated in here, and going to the GTS 250 it says 2008. And you can see that there's definitely a difference between both GPUs. Driver-wise, it seems not to be that simple though. The first version I tried, the much older one, only allowed to either enable or disable physics, and in here I can only do automatic, select the GTX 275 or the CPU. But I cannot select the GTS 250. Driver issues like that, and also the small quantity of actually supported hardware accelerated NVIDIA or Ageia physics games basically led to that these kind of hardware acceleration pieces were never a success. Of course, NVIDIA physics is still a very important technology. It's an important part of a lot of game engines right now and still up to date. And that's also why you don't need this kind of hardware acceleration anymore, because it's already directly implemented in the game engine, which also allows you to use it with a much bigger variety of components and hardware, which I think was the right direction to go. But I think it was a pretty nice technology back then. I loved back then when you had the first time realistic physics in games. It added a lot to the feel of a game and that it was something special, even though the pricing was completely out of hand. If you think about that, this card was about $300 US. That was just way too expensive, and one of the reasons why, at least as a hardware accelerated piece, it was never a success. I hope you enjoyed this video. See you next time. Bye bye.